Welcome to Maritime, Pakistan. Today, we are examining the International Convention on Load Lines, a critical piece of international law that dictates exactly how much weight a ship can safely carry. Limiting a ship's draft is a matter of sheer physics. When a commercial vessel takes on too much cargo, it sits too deeply in the water. Overloading subjects the hull to massive structural stress when plunging into rough seas, and it entirely destroys the vessel's natural stability. This diagram illustrates the primary concept known as a freeboard. The freeboard is the precise vertical distance from the waterline up to the ship's upper deck. The main objective of the convention is to maintain this specific space. Keeping the freeboard intact guarantees the ship's external weathertight and watertight integrity, keeping the ocean out of the hull. The load line is a strict mathematical boundary. It is the precise calculation separating a vessel that stays afloat from one that sinks under its own weight. The first International Convention on Load Lines in 1930 was relatively basic. It relied heavily on the simple principle of reserve buoyancy to keep ships above water. But shipping evolved and the regulations followed. The 1966 convention, adopted by the IMO, introduced a much higher level of engineering. It required complex subdivision and damage stability calculations to prevent the hull from tearing apart under stress. These sophisticated mathematical calculations don't stay on paper. They are translated into strict physical markers painted directly amidships on the side of every commercial vessel. International law is literally painted onto the steel. This visible standard ensures that any port inspector anywhere in the world can easily enforce the safety requirements. Beyond the painted lines, Annex I of the convention dictates the strict safety hardware required below the freeboard deck to keep water out of the hull. The rules mandate specific technical measures, including watertight doors, freeing ports, openings that allow water to drain quickly off the deck, and heavily reinforced hatchways. However, Annex I contains a fascinating structural exception. Ships intended to carry timber deck cargo are legally assigned a much smaller freeboard, allowing them to sit lower in the water. The logic behind this is highly practical. The tightly strapped stacked wood acts as a physical shield. It provides natural protection against the severe impact of ocean waves hitting the deck. The convention intelligently adapts to the physical properties of the cargo itself, maximizing shipping efficiency while maintaining strict safety standards. Calculating a safe load is not uniform across the globe. Annex II dictates that safety limits depend entirely on where and when a ship is sailing. This animated map divides the world's oceans into distinct geographic zones and seasonal hazard periods. A ship's safe freeboard limit actively changes mid-voyage. Crossing from a summer zone into a hazardous winter area automatically shifts load line requirements to handle increased storm risks. All of these varying geographic and seasonal limits are legally documented through the mandatory International Load Line Certificate under Annex III. A safe load line requires constant recalculation against the changing realities of global geography and climate. For a long time, updating these critical safety rules was legally difficult. Between 1971 and 1983, crucial amendments completely failed to take effect because the law required positive acceptance, meaning 2/3 of all parties had to actively vote to approve them. The solution arrived with the 1988 Protocol, which overhauled how the convention is updated and enforced on a global scale. This timeline visualizes the revolutionary tacit amendment procedure introduced by the protocol. This procedure flipped the bureaucratic script. Today, updates are adopted, deemed accepted after 2 years, and go into force 6 months later automatically, unless actively rejected by 1/3 of the parties. The 1988 Protocol also streamlined the maritime industry by harmonizing the convention's physical survey and certification requirements with other major treaties like SOLAS and MARPOL. Modern maritime safety requires a legal system agile enough to keep pace with engineering. Thank you for watching this presentation by Maritime Pakistan. Let us know your thoughts or questions on the Load Lines Convention in the comments below.